This is an example of numerical integration. We have done this before using a free fall example. So in your lab 1, you computed this analytically, that if an object falls, in this case a parachutist, if it falls from a certain point, what is its velocity as a function of time? Given that the drag from the air is linear, that is, it is some coefficient times the velocity. So we found that that velocity falls off exponentially to some terminal velocity over a given time. So if we want to find out how far the object has fallen over a given time, then we need to integrate this function over that time interval. So in this case, the question is how far the jumper has fallen after 8 seconds. So the answer to that question would be the integral of velocity from 0 to 8. And we can do an implementation using numerical methods, just like we did in the examples. But in this case, I will use Simpson methods to do that. So in this code, I have I won't run this line by line, but I will show you that here are the parameters of the problem, the mass, the g value, and c, and then we define a function f, which is the velocity function as a function of time. Our limits a and b are 0 and 8, and you can analytically find the value of the distance, but I'm using the numerical function built in MATLAB, and most probably in your applications you can use this function directly. Right now we want to also see what the results are for numerical solution. I divide the range from 0 to 8 into 2 second interval samples, and then I use the Gauss quadrature two-point method to compute the integral. So when I run this, I find that the value of the integral is almost the same as the value of the integral using the integral method. So this gives us a pretty reasonable estimate. And if we look at the, we need to clear this and rerun this so that we can see the plot. So as you can see, this is the plot of the velocity as a function of time. You can see after 8 seconds, it's the velocity is about 50 meters per second, and the area under this curve is 230 meters, which is the distance that the jumper has traveled.